So it's 6.02 times 10 to the 23rd. That's the number of atoms in a mole. And then there's going to be twice as many of them. So that's 1.2 times 10 to the 24 atoms. We can also ask how many grams of oxygen are in O2. Remember, if we look at the periodic table, oxygen has an atomic mass of 16. There's 2 of them. So it's 32 grams. How many moles of each atom are in 1 mole of H2SO4? So there's 2 hydrogens in each mole, and there's 1 sulfur, and then there's 4 oxygens. So basically, it's 4 times the number of oxygens because there's 4 oxygens in each molecule. All right, so the next question is how many of each atom, how many of each kind of atom are in 1 mole? So again, we can use our conversion. So basically 6.02 times 10 to the 23rd and multiply that times each of these numbers to figure out the number of atoms. So 2 times 6 times 02 times 10 to the 23rd, or Avogadro's number, is 1.2 times 10 to the 24th. And then for sulfur, there's just 1, so it is Avogadro's number. And then for oxygen, we multiply Avogadro's number 5 times 4, so that's 2.4 times 10 to the 24th. We can also ask how many grams of each atom are in 1 mole of H2SO4. So for this, we have to look at the atomic mass. So for hydrogen, it's got a mass of 1 gram. There's 2 of them, so it's going to be 2 grams. For sulfur, there's 1 of them, and it has a mass of 32 grams. And then for oxygen, there's 16 of them, or it's 16 grams, and there's 4 of them, so it's 64 grams. So if we add these together, we get 98 grams, which is the molar formula mass of H2SO4. So remember, the formula mass of H2SO4 is 98 grams. So if we have 1 H2SO4 molecule, it's got a mass of 98 atomic mass units. If we have 1 mole of H2SO4, it's 98 grams. We can also figure out mass percent composition of each atom in a compound using the mole concept. And again, we're going to use H2SO4. So we've just found out in the last slide, 2 grams of hydrogen, 32 grams of sulfur, and 64 grams of oxygen. And it's got a molar formula mass of 98 grams. So that's the total. So basically, if we divide each gram amount by the total formula mass of 98 grams, we get the mass percent of that atom. So for hydrogen, 2 grams divided by 98, and then you multiply that by 100 to get a percentage, 2% hydrogen. And then for sulfur, it's when we divide by 98 and multiply 100, it's 33%. And then when we take the oxygen, it's 65%. And if we add this up, you get 100%. It has to be 100 because that's all of the atoms are in this molecule. But that shows you the percentage by mass of each atom in the molecule. Okay, so basically, if to calculate the mass percent composition, just summarizing, we first of all calculate the mass of each component, and we calculate the formula mass, and then basically divide the first one by the second to get, and then multiply 100 to get the percentage. Okay, and I just want to emphasize here something that I alluded to earlier in this presentation is that we can do 2 different kinds of conversions with moles. We can take moles and convert to particles to find out how many particles we have, and we use Avogadro's number for that, so 6.02 times 10 to the 23rd particles per mole. And we can also convert between moles and molar mass. And for this conversion, we use the atomic mass, or we can also use the formula mass of a compound. So I'm emphasizing this now because we're going to talk about kind of going both ways, and sometimes you actually need to do both conversions within one problem, and you also need to be aware of which kind of conversion you're doing. Even if you only have to do one, you have to recognize like which type of conversion you're doing and which conversion factor you're going to need to use. Okay, so when we're doing practice problems, again, there's a couple. We can either convert particles to moles or molar, or between molar mass and moles. So the conversion factor we use depends on what we want to do. So at 6.02 particles per mole, and for the molar mass, you have to look that information up on the periodic table because it depends on the mass of the atoms or molecules or formula units that you're looking at. So let's do an example. We'll use H2SO4 again. And let's say that we have 0.5 moles of H2SO4, and we want to figure out first of all, how many particles are in that. So we start out by writing down 0.5 moles because that's what we're starting with. And then we got to find the correct conversion. So we look up top, we want particles, so that's going to be the 6.02 particles per mole. And then basically moles cancels, and we end up with 3.01 times 10 to the 23rd molecules. So a half a mole, that's going to be half of Avogadro's number. So 3.01 is half of 6.02, so that makes sense. So for the next question, what is the mass of 0.5? The mass of 0.5 moles of H2SO4. So in this case, the molar mass is what we want. And we need to look that up on the periodic table. So this is a compound, so we need the molar mass of all of the atoms involved. So again, for hydrogen, it's 2, each with a mass of 1 gram, so that's 2 grams. Sulfur is 32 grams from the periodic table, and there's just one of them. And oxygen has an atomic mass of 16, and there's 4 of them, so that's 64. So that's 98 grams total. So that if we had 1 mole, we'd have 98 grams. Here we have 0.5, so it's going to be essentially half of that. So basically, we can write that in there. So 98 grams per mole. And then the moles cancels, and we end up with 49 grams. And again, so that's half of 98. And another question we can ask is how many moles are in 315 grams. So this is a little bit different. So these are different kinds of problems you can solve with the mole. And so for this one, again, we always write down 315 grams. And in this case, we're going to want the molar mass conversion, and we already figured out basically what that is. It's 98 grams per mole. But in this case, since we're converting to moles, we want moles on top and grams on the bottom, so they basically cancel. And that would be, so if we have 315 grams, that is 3.2 moles. Now, sometimes we need to do more complex conversions. So, for example, you might know how many particles you have and want to know how many grams you have, or you might know how many grams you have and want to know how many particles you have. The way to do this is to use the mole. So you have to basically do this in 2 steps. You can't go directly from grams to particles. You have to figure out the number of moles first. So I'll give an example. Let's say we have a helium balloon that has a mass of 4 grams. How many atoms are helium are in the balloon? So the first thing we need to do, we can't actually convert straight from grams to atoms. We have to convert to moles first, and that's because essentially the mass depends on the molar. It depends on the mass of the helium atom, and the mole tells us essentially what that is. It tells us the molar mass. So we have a molar mass of helium is 4 grams per mole. And so basically, we're starting out with 4 grams. You always write down what you start off with when you're doing conversion first. So we're starting with 4 grams, and we're trying to figure out how to get to how many atoms. We can't get there directly, so the first thing we need to do is convert to moles. And the molar mass is 4 grams per mole, and we want to put moles on top, so grams cancels, and we end up with moles is what we want. And it turns out that we have exactly 1 mole in this situation. Now, once we have moles, then we can figure out how many atoms there are. So basically, it's 1 mole, and then we use Avogadro's number, 6.02 times 10 to the 23rd atoms per mole. That means we have 6.02 times 10 to the 23rd atoms. So again, we use the moles as conversion. So if we look at 4 grams and we don't know the basically the molar mass, we can't figure this out. So we have to convert to moles first. And here's a cute little conversion table. So basically, if we start with particles, we can convert to moles by dividing by 6.02 times 10 to the 23. And if we want to go from moles to particles, we multiply by 6.02 times 10 to the 23. And then we can also go toward from moles to grams. So if we multiply by the molar mass, we go from moles to grams, and we can go the other way from grams to moles by dividing by the molar mass. And then we can go all the way through in 2 steps, from particles to grams or from grams to particles. And if you're into cute little mnemonic devices, when leaving the mole, multiply, and then going back into the mole, dive into it. So use that if it helps, I guess. A couple of slides back, I showed you how to convert between particles and grams in 2 different steps. You can also do this in 1 step, and I'll show you how to do that here. So the Cornell Accelerator, which is at Cornell University, let's say that it produced 5.7 times 10 to the 22 particles of curium, and we want to know how many grams that is. So again, we have to go first of all from particles to moles. We can't go straight through. So we always start by writing down what we start with. So we're given 5.7 times 10 to the 22 particles. And then again, to get to moles, we want the particle to mole conversion with particles on the bottom and moles on the top. So we're multiplying. And when we do that, we have 0.094 moles of curium. Okay, and then now we're going to convert to grams. And to do that, it's 0.094 moles, which is what we just calculated. And then for curium, if you look it up on the periodic table, it is an element and it has a mass of 247 grams per mole. So that means that 23 grams were produced.